So to close our formal sessions, we are joined by Hart Montgomery. He's the CTO of Linux Foundation's Decentralized Trust Initiative. Hart leads open source efforts that advance blockchain interoperability and digital trust frameworks. In his talk, Open Source Decentralized Technologies, Why and How, he'll highlight how open collaboration continues to drive progress across the decentralized ecosystem. Please welcome Hart Montgomery.
Awesome. Can everybody see and hear me? Great. We have a small crowd, so please feel free to interrupt me, like ask questions. I'll be disappointed if I don't get at least one adversarial question. So, happy to do it. And let's make this as interactive as possible. All right. So I'm going to talk a little bit about open source today. This is going to be a little less technical and a little bit more like what Alireza talked about earlier. So I'm going to talk a little bit about the rationale for open source software. I'm going to talk about how I call it, how to have a good time in open source with a focus on some cryptography and privacy protocols. And then I'm going to talk about some examples that you can use from the Linux Foundation. So let's get started. So why do we open source code? Pretty much in cryptography, everything is open source. So I'm sort of preaching to the choir here. But one of the main reasons is, as I know Nigel brought up and some others brought up, you want to be able to verify the code, and you want others to be able to verify the code. For the academics here, you wouldn't trust a crypto system without a publicly available paper. Why would you trust software without a publicly available implementation? But there are also other benefits, right? We want others to be able to use and even contribute to the code. There are lots of economic efficiencies of open source, and a large ecosystem around a piece of open source ensures that if one organization goes away, development continues. And this is very important for things like practical security. So we use open source, right, for this transparency and this trustworthiness. And as I pointed out today, can anybody name a closed source cryptography piece of software that's popular? I'm assuming no. I mean, I can write my Caesar cipher and use it in my own application, right? I could even deploy it to Ethereum or something, but it's also easier to build software if we work together, right? De facto standardization often happens around popular open source software. Maybe if you're doing cloud deployments, you work around Kubernetes, for instance. Lots of independent entities working on a software project increase the chance it will last a long time. So even for closed source code bases, if you pay someone for a closed source code base, 90% of the application's code base is going to be open source typically. Looking around, I doubt we have any closed source advocates in the audience, but you never know. I was expecting some business people here. So I do want to point this out. Not the main point of the talk today, but there is tremendous economic value in open source. At the Linux Foundation, we have a bunch of resources on this. If you need to convince your management or something like that, you should be allowed to open source something or participate in open source, definitely check out these resources. Great. So what do I do? What does the Linux Foundation do? Why am I here? Well, the Linux Foundation solves collaboration for open source code. When multiple companies or people or whoever want to collaborate on open source software, but they don't trust one single party to own the code, they turn to the LF. And you can think of a lot of hypothetical examples, right? Maybe Amazon and Google want to work together, but they're competing in this space. So the code and the trademarks and all that stuff need to live in a trusted third-party organization. I don't want this to be an infomercial for the LF, so I'm just going to be quick about this. But I want to impress upon you that we do know what we're talking about when it comes to open source software. We're literally behind everything. You probably use dozens of projects in these foundations every day. Everything from Kubernetes to more advanced stuff like RISC-V, even fun stuff like the Academy Software Foundation, which does, or rather, which hosts the code for all of the animation software that goes into Hollywood movies. Just some numbers. I'm not going to read this out, but I hope I can just convince you that we've seen it all in open source, and if we do something one way, there was probably something bad that happened that made us do it that way. Right. So, any questions so far? Awesome. So, how to have a good time with open source? Who's anybody a South Park fan or watcher here? How to have a good time with open source. So the first thing I want to mention, and I asked this question earlier, is to pay attention to licensing. Probably the most critical thing in open source software is the license, right? It's just a legal document that records and formally expresses a set of policies around the code. I know we have some cryptographers in the audience that probably think licensing is the most boring and useless thing ever. But I have to tell you, it is important and you do need to pay attention to it. Three general types of licensing today. We have BSL licenses, copyleft licenses, and permissive licenses. Has anybody here used a BSL license or issued a, yep, yeah. It's technically not an open source license. It's actually what's called a source available license. The code is public, but limited to certain users. And this is sort of a nice compromise between proprietary software and open source. You get the verifiability of open source software, but you restrict others from using it. So, again, use a BSL license when you want people to control your code. You want to be able to control your code still, but you want people to be able to independently verify and study your code. Right. So copyleft license. This is sort of a very complicated thing. It requires that users make available all derivative works. So basically, if you take code and you use it in something else, then you have to make that whole something else available for free, right? There's a quote from Richard Stallman here. It's often called the GNU virus. That is a quote from Richard Stallman himself, who designed this. The license was designed to make it so that everything was forced to be open. And I will warn you that this is very hard to use commercially. The goal of the copyleft license originally was that it was to increase contributions back to code bases by legally requiring them. The reality is that typically people just won't use your code if there are any viable alternatives. Relicensing is a really awful pain. If you don't believe me, go look up the OpenSSL relicensing that happened about 10 years ago. You can just, you can see the carnage. It's really, really hard to do. So you should pick carefully. And finally, there are permissive licenses. I assume everybody here has used code with a permissive license. It's the way to go if you want others to use your code. It's by far the easiest to use. Most commercially used open source code, most LF code bases are licensed with the permissive license because it's by far the easiest to use. I think all of the relatively new LF code bases are permissive. And by relatively, I mean like 10 years. But yeah. So we typically recommend that people default to permissive licenses if you want to do research code, or if you have code that you don't have plans to directly monetize, just because it maximizes the number of people who can use your code. I will say a lot of times you have to be careful because people may unintentionally or maliciously add code that has IP protection. The LF kind of learned this the hard way. So there was this whole series of lawsuits. It was very not fun. It was like a 10-year process. To protect yourself from this, we recommend that you use the Developer Certificate of Origin, the DCO, or a CLA. This is really important if you have contributions from people outside of your company. So if you're working on a code base and you have a helpful contributor, it may seem annoying, but you really need to get them to sign a DCO or a CLA, or you could potentially be in a lot of trouble later on. Just to show you, this is what the DCO looks like. You don't need to read it all, but it's just really that simple. It has GitHub integration, so you just sign your commits with a -S flag, and that's it. It's really, really easy. Does anyone have any questions so far? We're good? Okay. So security. You guys already know, you folks already know that security is essential. I want to point out some things that are slightly different for open source software that you may not consider. So the 3 things I'm going to bring up today are vulnerability disclosures, SBOMs, and software authentication. We have a foundation at the Linux Foundation called the OpenSSF. Has anybody heard of this? No? Okay. So this is a community that works together for, as you might guess, open source software security. They have really, really good checklists and sort of basic procedures to follow if you want to have a solid baseline of open source security. I definitely recommend going through just to make sure you haven't missed something. Check it out. So as we mentioned before, one of the big advantages of open source software is that community members can find and report bugs, right? But you need to make this as easy as possible for them. So we recommend a security response team. We use a lot of the GitHub tooling. And it doesn't really matter the method you prefer as long as it's easy to find and follow. So who has a pipeline for their open source projects? Anybody? Okay, definitely set one up. We use a lot of the GitHub tooling. It can be complicated. So we have a project called Besu, which is an Ethereum execution client. It has 7 reporting channels. It's very difficult to handle, but definitely set this up. And I will say, if you're a user, don't be shy about reporting bugs or vulnerabilities. Maintainers much prefer false positives than unreporting bugs. Generally know your maintainer as well. So moving on. When people build modern applications, and this goes for both a closed source application and an open source application, right? They typically use open source libraries to solve problems, but they use a base framework, and sort of custom code is a very small part of the overall application. So what does this mean, right? Everybody has to have seen this XKCD before, right? Yeah. So these kinds of software supply chain attacks have been becoming more and more prevalent. Are people here familiar with the XZ-Utils attack? It was sort of really clever and sort of a long-term malicious attacker. You raise your hand if you know this one. Couple people? Awesome. Yeah. So, very concerning. This is a fun fact. So there's a Black Duck report that audited 1,000 popular code bases across 16 industries. 81% of these contain high or critical risk vulnerabilities. 90% contain open source components more than 4 years out of date. Basically, most modern code bases are a disaster. The moral of the story is, and what could help solve this problem, is using software bills of materials, or SBOMs. This lets you keep track of all the code you pulled into your project. If there are bugs, you can fix them because you have integration with CVE notifications for all of your dependencies. There's a tool called Guac in the OpenSSF that can help you set up an SBOM if you need to do it. And finally, software and artifact authentication. If you build a popular project, people will attempt to impersonate you. We've had this happen twice already this year for projects that I work on in NPM. It's sort of ubiquitous. So we recommend you use software authentication tools. Sigstore is a great one. You can check it out if you want. And finally, we encourage people to look at the community. one of the keywords about this definition of open source software is collaborative public manner, right? Sorry, thanks for speaking up. SIG store. Yeah, check it out. Check out all these tools. Just browsing through the OpenSSF, they have something like 8 to 12 working groups. They're useful. Even if you've worked in cryptography for a long time, there's still a lot of I's you need to dot and T's you have to cross. And it's just good to have a checklist. And it's even better so you can show others, if you want people to have confidence in your project, you say, hey, we did all the, we did the basics at least, right? So thank you for the question, by the way. Developing in a collaborative public manner is important because diverse communities and large communities bring a lot of positive things. And it's really important to sort of separate out open source. When we talk about open source, right, it could just be a public repository of code. We also talk about open development when there's a community building open source code. And then there's finally open governance with procedures and roles for the community, how decisions are made, and the roadmap definitions. So open source governance is very broad. We sort of divide this into 4 broad categories, although you certainly could find things that are not exactly in one of these categories, right? We have things that are public demonstrations, which are just sort of like, code dumps, right? You can see the code. There are open products, which is when people develop in the open, but sort of, they don't allow outside contributions. They're benevolent dictator projects, right? Where contributions are allowed, but the ultimate authority on merging code is still a single organization. And then finally, there's open governance, which, it allows anyone to join and contribute. There are inclusive, clear public processes for leadership with organizational flexibility. And generally speaking, it can be more challenging and sometimes, scary for people and companies to move to the right on this screen for governance. But generally speaking, the more openly governed you are, the more people will use and contribute to your open source software. But whatever you choose, it's important to thoroughly document open source governance. Awesome. Any questions at this point before I, move on? Nope. Awesome. So privacy and the elephant action. So we have a bunch of decentralized projects. Some of these you probably recognize. Besu is a popular Ethereum client, particularly in the enterprise space. Hyro is the full Hashgraph code base. Lots of different things. I will point out, all of our privacy projects, they're Apache 2, they have DCO required, there are no IP restrictions. You can just use them for whatever you want freely and without worry today. Go download them. We follow best security practices. Our open governance is mandatory. And if you want to see who's contributing to and working on the project to make sure it's sort of stable and enough, you can check out our Linux Foundation analytics, which show all this in the clear. So some privacy projects that I'll talk about today, just highlighted here. So the first thing I want to talk about briefly is Paladin. Has anybody heard of this? There have been a lot of talks about this week. It's sort of a middleware framework for privacy for EVM. The idea is you can take a privacy policy or technology and sort of plug it in and you get all of these different features. I'm not going to read this off, but it is a large thing. And again, the really nice thing about privacy is sort of just the modular framework. There are a number of privacy protocols that are already implemented and come with the protocol, but you can really use a lot of different stuff. I know, for instance, that people have tested the Zama stack through Paladin. Obviously no production deployments, But if you want to run an FHE VM in this framework, you can do it. And it handles a lot of the plumbing and middleware for you. And some of the annoying aspects when you want to deal with tokens. I think everybody knows the native EVM lacks privacy, but the way Paladin works is, again, it's this middleware stack that lets you heavily tailor privacy to what you need. The most popular solutions we see today are sort of, three kinds of, well, really two kinds of privacy. There's this trusted issuer model of privacy. That's kind of the notary model, which is similar to sort of what R3 Corda or Canton use, if you're familiar with that. And then sort of full ZK tokens, which you can think of as sort of like a souped up Zcash model, if you're familiar with that. Great. So another project, Loch Ness. Are people familiar with this? Yes, so this was contributed by Defense. There are a number of academic papers on this. Jonathan Katz gave a talk at Crypto a couple years back about some of this stuff. It was a great talk. What it is, it's essentially MPC for a lot of things, particularly around threshold signature schemes. And the focus is key management and key security. They have a really nice system. It's always really fun to look at their content because every time there's a wallet hack, they show why their wallet wouldn't have been hacked. Definitely check it out if you're interested. I'm going to briefly talk about some decentralized identity projects. Has anybody heard of this Bhutan National Identity Program? No? Okay, this is a really cool thing. First, to my knowledge, a national scale digital identity program. It's based on a very simple anonymous credentials protocol. It's on this Credible project. Going to sort of the first digital wallet, this goes back to like 2017. The British Columbia government created, a whole decentralized identity ecosystem based on Indy and technology that's now in the Open Wallet Foundation. Very flexible. You can even do things like if you're a licensed lawyer, you can prove in zero knowledge that you have a legal license. And this is, fully endorsed and supported by the government. KYC. So KYC is hard. Cryptographers tend to oversimplify KYC just because of the legal regulations allowed. I'll say as an anecdote, I was at the Bank of International Settlements a couple months ago, and I was asking, what's the formula for KYC? How complicated is it? Not only can they not tell me the formula, they wouldn't even tell me the inputs to the formula. It's tricky. But in some cases, you can do it. And this instant solution, based on a whole stack of technology, is a KYC solution for a select problem. And finally, the last identity application I'll mention, again, with mostly Open Wallet Foundation technology, which is a Linux Foundation project at this point, was based on employment verification. So people being able to prove in zero knowledge that they're employed by a particular employer. So digital identity is rapidly evolving. You heard Abhi talk this morning about the cutting edge, but I think it's worth noting that some of these things are already in practice. Then I'll say we have a whole identity standards organization called Trust Over IP. I'm not going to sort of read this all out to you, but there are a lot of interesting protocols here. Many of them could really use cryptographic review. So I'll just throw this up there. Finally, a very recent project called Minakawa. It was contributed by Shilda Technologies. It's designed around the compact language. Has anybody seen this? There are a bunch of papers from IOG on this. It's very strongly academically supported. And it's a statically typed bounded smart contract language, has really nice on and off-chain separation and functionality. Some common features. I think the really nice thing to point out here is the strong static typing and the separation of public and private state. Makes it easy, really easy for developers to use. I don't need to read all that out to you. So I do want to conclude by mentioning some labs that we have, some very new stuff in development. One of the more interesting things is a generic ZK snark standardization effort. This is being led by the PS&E team from the Ethereum Foundation. And the goal is to standardize the high-level components of snarks. Essentially, the snark ecosystem is changing so rapidly as people write more and more papers and come up with more efficient solutions. And we don't want developers to have to completely redesign all of their code every time someone invents a better snark. So the idea here is that we could standardize some interfaces, and hopefully when maybe someone in the audience invents the next latest, greatest snark, the developers don't have to completely rewrite their code. The next thing I'll talk about is this ZK-BK lab. It's a collection of zero-knowledge gadgets built to facilitate this thing we call first-person credentials. There's an 80-page white paper on this if you really want to see it, but the basic idea is this should be a web of trust and sort of a proof of personhood and a way to do decentralized reputation systems and reputation proofs. And it was called this weird thing because the Berkeley people wanted to call it that. Finally, a project very recently contributed to the labs called Nightstream. It doesn't exist much yet because it just got started. There's not a lot of code or anything. But the goal is, well, a lot of people decided that they wanted to invest in creating a post-quantum ZK proof system with a lattice-based architecture. And this is coming from I.O., Stanford, Midnight, and Shielded. So interesting initial committers, if you're familiar with those people. I'm not sure how much code they'll actually write, but they sign their names up. Yes, both of them do. Scope and development, this is just an ambitious, very ambitious scope coming from Charles at Cardano himself, among other people. But if you're familiar with ZKs, this is probably what you'd want. And then finally, you all just heard about Didi, so I'm not going to mention this. And I will conclude because I'm standing between you and beer o'clock and offer to answer any questions.
Oh, thank you. If you go back a few slides to your zero knowledge one, hold on. This one, that one, yeah, that one there. So this is a good idea, but it kind of assumes that all snarks are going to be working via arithmetization.
Yes, you are correct.
So what we're seeing is that a lot of them are now going to virtual machines. They're processing WASM bytecodes and stuff like that. So in some sense, you might actually be standardizing for the past.
Definitely agree with you. This is a completely open organization.
Yeah.
I would be thrilled if you would comment this on the lab GitHub.
Far too much hassle.
All right, but you're exactly right. It's not entirely clear how to standardize these in the best way.
They've been doing this in, so for example, IEEE have got a standard they're trying to do for MPC. And it's one of these very high level standards to do the high level components. And ISO have been doing a similar thing for FHE. And there's been this zero knowledge standards organization and they want to do the high levels things. And the same with FHE. And they almost all fail because they end up standardize in the past, and then everything, and because they're not working fast enough, because they don't want to get down in the weeds because it's moving too quickly. So you think they're going to do the high level thing, but the high level thing is also not static either. And so, yeah, it's kind of...
Yeah, you're totally right. And one of the reasons people have been coming to the LF for standardization, which is certainly not a traditional thing, is because it's possible to move faster. You can update, if you go to like, the IETF or the W3C, sort of one potentially malicious actor can cost you multiple years of time if they so desire, right? ISO is a whole different beast. ISO is very, very closed. So we can't even really work with ISO. It's, sometimes they ask, but, we have to sign all these legal contracts, NDAs. The LF, I think, is across the entire org, signed 3 NDAs in its history. So, it's just not something we do. So yeah, we don't even work with ISO. Any other questions? I'll be around the Fintech week through Thursday. So, please talk to me. Happy to answer questions. I'm pretty easily findable. So definitely email me if there's anything I can do to help you. Oh, question.
They would give it to you to manage. Is that?
It's not exactly. So when projects come in, typically the maintainers are the same. We don't try to control people or projects. Our mission is to be sort of a neutral third-party framework where people can collaborate in the open. So if you contribute, a project to the LF, I'm not going to come in and tell you, this needs to be your roadmap. You have to implement this feature. I'll get pretty upset if you're not responding to your security vulnerability reports. We might ask you to leave if you, don't follow best practices.
So you're not protecting against malicious internal actors?
Well, it depends on how you define that, right? It's sort of like, a BFT system. We try to set things up. So if there's one malicious actor in a broader system, right, then the governance protects against that. If an entire project set of maintainers is malicious, then it is contained to that project, but, and if they start doing things that are, that sort of violate open source best practices, we might ask them to not be in the Linux Foundation anymore. But in general, yeah.
Well, you mentioned that you would prefer an adversarial question as well.
Sure.
So a counterexample for something being open source, a counterexample for the value of being open source is that I think it was Fireblocks who wrote a blog post against BitGo where their implementation of GG20, their experimental implementation of GG20 threshold ECDSA did not contain any zero knowledge proof, and by that time the damage has been done, and it wouldn't have happened if the code was closed source. So yeah, BitGo was fine even though that the code was experimental and nobody was using it.
Yeah, I mean, in this case, we do encourage people, and we have a whole internal system of basically marking maturity of code. So we do encourage people to clearly define, what stage the code is in. And presumably, I don't know personally about this case, but presumably if they flagged this code as, extremely experimental, do not use, do not touch, the fallout would have been less. So, this is just all about transparency, right? You just tell people, this is what we've done, whether it's, we've had 3 security companies audit the code, and we've spent tons of time on security, or we just vibe coded this together, and who knows. As long as you're honest and transparent, you'll rarely get into trouble with this kind of thing. But thank you for the question. Awesome. Well, I don't want to keep you all from beer o'clock. So thank you again for your time, and please feel free to reach out if you have any questions.